Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 24th of June, 2025, T 17 hours, 59 minutes, and 58 seconds, .0000Z. This paper, published just yesterday, introduces a new framework that can animate complex 3D models in about 6 minutes, a huge speed up from older methods that could take 25 hours. The paper is titled AnimaX, Animating the Inanimate in 3D with Joint Video Pose Diffusion Models, and the results are really quite impressive. Essentially, this paper presents a way to create high-quality animations for almost any kind of 3D character, from people to animals and even furniture. Also, the authors shared their official GitHub repository for AnimaX. It looks like the code and models aren't public just yet, but the page is up with a to-do list promising their release soon. So it's definitely the right place to watch if you want to try it yourself. Alright, so this first figure gives a great visual for what the system does. It shows this kind of animation factory where different 3D models, like a person, a fantasy creature, and even a treasure chest, are fed through and come out with new motions. The key here is versatility. The method works by first using a special AI, a joint video pose diffusion model, to dream up both a video and the character's pose simultaneously. Then it uses a technique called inverse kinematics, which calculates the necessary joint angles to build the final 3D animation. Building on that idea, this table really puts the AnimaX framework into perspective by comparing it to other animation methods. It's one of the only approaches that is both skeleton-based, meaning it uses that controllable internal skeleton we just talked about, and can handle multi-category models. But the most striking comparison is the cost time. While some other methods take minutes, the most similar competitor, AKD, takes a staggering 25 hours. AnimaX, in contrast, takes just 6 minutes. This unique combination of versatility, control, and speed is what really makes it stand out. So this next diagram really unpacks the magic behind that 6-minute animation time. It shows the whole 2-stage process. You start with a 3D model and a text prompt, like a boy jumps up. This feeds into a joint video pose diffusion model, which is a clever AI that dreams up both a video and a corresponding stick figure pose sequence simultaneously. It uses what are called shared positional encodings, which are basically digital tags to keep the video and pose data perfectly synced. Finally, it uses triangulation, a geometric technique, to rebuild a 3D skeleton from those 2D poses. Moving to the results, this table provides the hard numbers. It compares AnimaX against other methods like Animate 3D and Motion Dreamer on the VBench benchmark. The metrics here measure things like how consistent the animated character is with the original, that's the I2V subject score, as well as motion smoothness and overall aesthetic quality. On all of these key metrics, where a higher score is better, AnimaX comes out on top. This data really backs up the visual quality and shows that the whole process we just discussed produces state-of-the-art results. And this next figure really gives us the visual proof for those benchmark scores. It's a direct, side-by-side comparison with two other state-of-the-art methods, Motion Dreamer and Animate 3D. You can see for the bat the other results are a bit stiff or blurry. For the table, one method has the drawer just fall apart. The AnimaX results on the right are consistently more correct and authentic. This visual evidence shows how its skeleton-based structure prevents the strange melting or deforming artifacts that can happen with other approaches. This next figure really digs into why the method is so effective. It's what's called an ablation study, basically taking parts away to see what breaks. On the left, if you just try to predict the pose from text, the motion is static. The bat's wings barely move. In the middle, without what are called shared positional encodings, which are essentially digital tags that sync the video and skeleton, the pose becomes inconsistent. But the final result on the right, using the full model, shows a fluid and correct breakdancing motion. Alright, so to wrap things up on AnimaX, what we've seen is a really elegant solution to a tough problem. It successfully bridges the gap between the creative but often unstructured world of video generation and the precise control of skeleton-based animation. The key takeaway is its incredible versatility and speed, being able to animate almost any 3D object with a skeleton, from a person to a piece of furniture, in just 6 minutes. This really opens the door for much more accessible and diverse 3D content creation. That's all for this week's AI Research Roundup. Thanks for tuning in.